What a great story that was. So let me just wrap up by giving you some closing comments about what I see happening with technology and society and why Andy and I founded the Initiative on the Digital Economy. We see some tremendous changes happening in not just the technology, but the way it's affecting the economy. And we want to create a research center that would go after understanding those changes. We see the bottleneck not so much anymore in pushing the technology, Moore's Law, or some of the other amazing technologies further and further, but understanding how our society would be affected by them. What are the economic implications, the social implications, the business implications? More and more, that is the bottleneck. Like the example that Andy gave of how when factories electrified, it wasn't getting access to electricity, it was rethinking their business models. And we're now doing that on a more profound society-wide level. And I think that the next 10 years are going to be some of the most momentous ones for our society. And the biggest challenge for our society will be grappling with the way technology is transforming the workplace, transforming our relations with each other, transforming society. And so I want to take a few minutes to talk a little bit about what I call the AI awakening and the challenge for society. Our last book was called The Second Machine Age, and we talked about how after machines helped augment and automate a lot of physical work, they started working on helping with mental tasks, being able to help us make decisions better. And we are now entering what Andy and I would call the second wave of the second machine age. But to give you some context, let me describe a little bit what the first wave of the second machine age was. And that was having machines think, but basically by telling them what to think, by taking what we already knew and codifying it. Coding is basically another word for codifying knowledge. And that was a tremendously valuable thing, to be able to codify knowledge and get machines to do those things. It's really a multi-trillion-dollar industry, and once you codify something, you can digitize it, and then you can replicate it. And many empires were built, and a lot of productivity was increased in areas like payroll processing, ERP, mobile apps, and so forth. But powerful as that was, it had a very fundamental limit. And that limit actually has a name. It's called Polanyi's paradox. Michael Polanyi was a polymath and philosopher, and he pointed out a very important fact, which is that we all know more than we can tell. We know how to ride a bicycle, but it's very hard to write down instructions to tell somebody else, oh, here's how you ride your bicycle. You put the foot in front of the other, or recognize a face. These are things that we know how to do, and we can do them quite competently, but if we can't describe them to other people, how are we going to codify them and explain them to a machine? Anyone who's coded, you know you have to be very precise when you write computer code. If you don't, it won't follow the instructions and it won't work at all. One of the classic examples that Polanyi gave was recognizing a face. That you could recognize your mother's face or your brother's face in the audience, and that'd be easy to do, but telling someone else what to look for and writing down code would be very hard to do. So he just thought that was something that was beyond the grasp of codification, which limited what machines could do. But of course, that's changing, and we heard about that today. The machine learning revolution is kicking in. And if you've been on Facebook, you know that now machines can recognize faces. Not because we wrote down code about how far apart each person's eyes are, but because there's a different approach, which is having machines learn the rules on their own by giving them examples. And this machine learning approach opens up a broad new space. All those things that were subject to Polanyi's paradox, now machines actually can start doing them. It's just early days, and we heard, especially in the first panel, a lot of potential for the future, but most of them haven't kicked in yet. But I think we can see that wave is coming, and it's part of this broader subcategory of artificial intelligence, machine learning, especially deep learning, that's kicked in. And it's able to do some interesting things. We saw some of them today, but I want to show you this particular example. It's kind of fun. This is an example of how machines can learn new strategies in games. And have you ever played some of the Atari video games? It's interesting that a team at Google DeepMind took the raw pixels from this video game. It didn't tell the rules or anything, just the pixels, and told the machine, okay, here are the pixels, here's the controller, you can move it around left and right, and here's your score. Go try and maximize the score. It didn't give it the concept of a ball or anything like that, but it started learning quite rapidly. And if we can run this video, you can see how the machine worked. After 100 games, it sort of was randomly moving the paddle around, and sometimes would hit, sometimes would miss, but every once in a while I'd get lucky and get some points and say, hey, whatever just happened, I want to do more of that. This is a reinforcement learning algorithm. After 300 games, it started getting pretty good. It almost never missed. Good is a pretty good player. And they were pretty happy with that, but they just decided to let the machine learning algorithm keep going and see what would happen. And after about 500 games, they were a little surprised because the machine started doing something new that they hadn't expected it to do. It did this tunneling strategy, sending the ball around the back. And the programmers, I talked to them, they said, oh, we didn't know they could do that. That's kind of cool. So the machine was kind of figuring out new things. And you heard on the panels that this is not just an isolated example in a video game. They're designing new kinds of heat exchangers and drawing things and poems. So they are learning new things on their own if we can specify the situation very well. And there have been 3 big applications already that are making enormous effects, and we can see what's going to play out over the next, I'd say 10 or 20 years or so. The first big category is in vision and language, and then interacting with the physical world, and then problem solving. So in vision, I think we've crossed an important inflection point. I had to show a picture of puppies because they're so cute. Muffins are cute too. Just be careful you know which are which before you eat them. It can be a little tricky sometimes to recognize things, and humans are not perfect, and machines used to be very far from perfect. Back in 2010, they had about a 30% error rate on this big database called ImageNet. It has millions of images that have been painstakingly hand-coded by Fei-Fei Li, who we heard about a little bit, and others organized that. And there have been attempts to try to teach machines to recognize objects. And as recently as 7 years ago, they got about 30% of them wrong. But then they started improving quite rapidly. And that was when this deep learning revolution kicked in. Neural nets started being used, and they substantially improved the success on ImageNet to the point where it's down less than 5%, 3 or 4% error rate now. And that yellow line there that you see, that's the error rate of humans, because all of us sometimes have a little trouble distinguishing puppies from muffins or other things. So we are now at a stage where the machines can recognize objects, at least in ImageNet, which is a constrained set, as well or perhaps better than humans. And that's not just a difference of degree, that's a difference of kind. Because if you are an entrepreneur or a manager and you have 2 options for solving a task, and one of them has now become better than the other, well, that's going to change your preferences. It's like when you heat water up to 100 degrees Celsius, at some point, there's a change, a phase change. It's not just 1 more degree. It's a whole different ballgame when it becomes steam and can power things. And that's what's happening, beginning to happen in vision systems. And Vinod Khosla talked about how, for instance, radiologists and cancer detection, image detection can be improved because these systems, if you show them lots of examples and say, hey, this is not cancer, and these other examples, this is cancer, it can learn to recognize things. And the systems now can recognize the key markers of cancer that are taught to pathologists who go to school for 12, 16, 20 years learning this. The machines can learn them. In fact, the machines on their own, like with that game of Breakout, have identified some new markers that no humans had ever really noticed before. So they're even getting better at that. We also see things happening with speech recognition. Google I/O presented the improvement from about 8.5% to 4.9%. Again, humans are not perfect. Humans are in the 4 to 5% range, depending on who you're talking to. Some of them better and some of them worse. But what's interesting about this trend here, this rapid improvement, this is not over the past decade. This is not over the past 10 years. This is over the past 10 months. Okay? So we are just seeing breathtaking leaps and bounds in the ability to recognize things. Having talked to Siri and Google now, I still think it's a little clunky. It's not quite there where I want to use it all the time. But Andy and I just did finish writing an article, and a good chunk of it we dictated because it just turned out to be easier. In fact, there's research that dictating messages and text works out to be about 3 times faster than typing it now. So as Vinod was saying, I think we're getting to a new kind of conversational platform, and there are a number of different kinds of applications for that. A second big change is interacting with the physical world. We see improvements. Let me see. Why is that not showing there? In mobility, we see vision systems allowing cars to recognize each other. At Mobileye, early versions of their systems used to make about 1 error out of 30 frames in recognizing pedestrians. You wouldn't want to have that in a running production system. Now it's about 1 error per 30 million frames. So a really million-fold improvement there. Our colleague Daniela Roos has helped, and others at MIT have companies that are doing some of these self-driving cars. If you go not just in Mountain View, but down in the Seaport area in Boston, you can hop into a self-driving taxi around a constrained area where it will go, and you can use that. Sang-Bai Kim has some cool, kind of scary creatures that run around MIT. I was at the MIT Fitness Center, and one of these was running laps around the track there. Runs 28 miles per hour. Actually, it was even more impressive than that. They were throwing things in front of it. They'd throw like a chair or an object in front of it, and it would leap over them. So this is real. This is not something from some special effects science fiction movie. This is a physical thing that we have running around there. And they're, of course, going to work in factories. Rodney Brooks, who used to be in charge of the AI lab at MIT, has a company called Rethink Robotics. And robots like Baxter can work for the equivalent of about $4 an hour. But they also learn on their own very easily. You don't have to program them. You can just hold their arms and say, hey, reach onto this assembly line, this conveyor belt, put it into the basket. And this is a job that millions of people are doing jobs like this around the world. In fact, Rodney says a lot of people in Massachusetts, that's what they do all day, is they take stuff off the assembly line. But now the machine can do it a lot more cheaply and efficiently. And perhaps most profoundly is in the area of problem solving. I showed you that video game. It's kind of a fun toy application. But this one is not a toy. This is a giant video game, if you will. You could take a data center with thousands of dials and levers and feed that information into a reinforcement learning system and say, hey, your score is energy consumption. See if you can improve energy consumption, make it more efficient. So they did that. They ran it, and the machine learned. And this was a data center, by the way, that had already been optimized by a bunch of super smart PhDs in operations research, because these things cost billions of dollars, so they want to make them as efficient as possible. But the humans got it to a certain level. The machines got it to a much better level. You can see before the machine learning control went on, the power utilization efficiency was pretty inefficient. Here, down is better. It improved by about 40%. And then when they turned it off again, it got bad again. So this machine had figured out how to run the data center much more efficiently. And you can imagine that's not just one data center. You can take that technology, apply it to all data centers, which is a huge cost area for Google and for most tech companies. And it doesn't take much imagination that if you can do it with a data center, could you do it for inventory control in another organization? Could you use it for all sorts of continuous process manufacturing? So there's some big opportunities there. This is all quite recent. And you can do it in the service sector as well. I was talking to the folks at JP Morgan, and they have thousands of people who are doing a lot of very routine work who they think now machines will be able to do the work they're doing. A lot of those people are being paid hundreds of thousands of dollars a year, they say, but nonetheless, the kinds of tasks they're doing, at least parts of them, could be increasingly automated. So I could go on with lots more examples, but let me just turn to thinking about what does this mean for business and the economy. And the first thing I want to emphasize is this is mostly, and it should be really good news. It's going to make the economic pie much bigger. I don't think, as I pushed Carl and Vinod a little bit, I don't think most of it has shown up in the productivity statistics yet. Part of that's a measurement problem. But I think most of it is because it's still kind of in the future. Those self-driving cars haven't had much of an impact yet. Neither have most of the other examples. that I just showed you, but they will. We can see where they're going, and that's really good news to make the economic pie bigger, and also in ways that we can't measure, whether it's in health and welfare and other areas that don't show up very well in the productivity statistics. But another important fact is that there's just no economic law that everybody is automatically going to benefit. It's possible for some people to be left behind. In fact, if you check the textbooks and flip through, there's nothing that says that you couldn't have a majority of the people being left behind. Now, that's not what's happened through most of history. The good news is that there's generally been a rising tide that lifted most boats. But recently, it's been not working out quite as well as that. And there are a number of reasons for that, but more and more economists are thinking that the way that technology is being used is a part of it. Productivity continues to rise. It is an all-time high. We have more millionaires and more billionaires than ever before in history. But the median income, the 50th percentile, has been pretty flat since about the late 1990s. And Andy and I first wrote about this way back in 2011 with Race Against the Machine, and we said that these technological advances are helping some groups, but others are not participating as much, whether it's because of skill or superstars or the capital share. They all lead to different winners and losers. And more people, I think, are coming in with this view now. There's a litany I can point to of some pretty smart economists and others who have looked at it. I just finished co-chairing a report of the National Academy of Sciences. Larry Katz, who runs the leading journal, they see automation as being the key driver behind this transition. And again, I don't want to say it's the only one. And the concept that I want to point to is what we call biased technical change. Bob Solow at MIT got a Nobel Prize for talking about how technical change could make the economy bigger. In fact, was the main driver of it. But his models were mostly fairly simple, and they just had technical change affected everything. But you can also have a slightly more complicated model which said technical change affects different inputs in different ways. For instance, you could have skill-biased technical change, and people who went to grad schools maybe would do better than people who went to high schools or high school dropouts. And that's what we've seen. In the early part of the century, it was a rising tide. All groups improved. Since then, you can see it fanning out. And there's a couple of groups that aren't participating much. Just to calibrate this for you, the median person in the United States is that green line. They've gone to some college. They have not graduated from college. So tell your kids to go to college. Another factor is the allocation between capital and labor. When you take those cars and make them self-driving, it makes the pie bigger, more convenient, but it also shifts how much goes to capital owners versus how much goes to labor providers. And it's already something that we see in the data. If you look at the blue line here, kind of bounces around, been trending down a little bit, but has fallen quite steeply lately. And that's the share of the total GDP that's going to laborers or to workers. And then the last one I'll show you is what I call superstar bias technical change. This idea that you can use technology to replicate skills or talents or insights. And as Patrick Collison was saying, we're getting to more and more of a winner-take-most or winner-take-all economy. And people talk about the 1%. This is not the 1%. This is the 1% of the 1%. They have their own 1%. And they are at an all-time high now in terms of the share of total GDP that's going to them. And again, I want to stress there are a number of factors at work, but clearly one of them is the ability for technologies to take these skills and talent or luck and replicate it to millions or even billions of people. And if you are one of those people, you can do very well. But if you're one of the people on the other side, maybe you have a harder time. So these technologies are advancing quite rapidly, but I think our organizations, our skills, are not keeping up as much. Just like back in the days of electricity, we have to do some reinvention to take full advantage of them. Right now, millions of people are being left behind. That's what the data say. But I wouldn't point the finger at technology as the culprit. It really has a lot to do with how the technology is used. As we heard just a minute ago from Parag and Devin, you can use technology to create more inclusive innovation, and we can invent institutions that create more broadly shared prosperity. In the first machine age, when millions of people went from farms into services and manufacturing. 90% of Americans used to work in farms, now it's down to 2%. Those people didn't simply become unemployed or have their wages plummet. Instead, we worked very hard to transition them, to reskill them. We invented mass public education, and we invented new policies in antitrust and Social Security and progressive income taxation and a bunch of other policies that led to shared prosperity as opposed to simply saying, hey, too bad for all you guys, we'll leave you behind. And I think similarly going forward, we need to come up with the new kinds of policies and institutions and new kinds of organizations that will lead to that kind of shared prosperity. They're not going to be the same. We can't just do the exact same thing we did back in the 1800s or the 1900s. We'll have to keep thinking about new things. But it's probably not the case that just sitting back and doing nothing is going to lead to an optimal outcome. But understanding what those are, what those changes are, is a big part of what we do at the Initiative on the Digital Economy, understanding how individuals, businesses, and society more broadly can take advantage of these technologies to benefit more broadly. Just as any kind of a tool can be used effectively or to hurt people, whether it's a hammer or a digital technology, we now, I think, have a new grand challenge that we just heard about in the last session to try to use these digital technologies to leverage our skills and invent new organizations and metrics, because just doing the same thing isn't going to be fully taking advantage, isn't going to lead to the kind of growth and shared growth that we'd like to have. So let me just wrap up by saying any of you who would like to learn more about it or get more involved, you can help shape the future. You can go to this URL, which is the Initiative on the Digital Economy. We have an enormous number of research papers that you can read there. You can tune in and watch most of our conferences and events. We stream them. You can come and participate. You can participate in our action learning labs, like the analytics lab. You can come to our other workshops and conferences. Or you can support us in any other way you'd like to help us make this transition. I do think it is the grand challenge of our era, the grand challenge for our society, and we have a great opportunity to make it the best thing that ever happened to us. But I also don't think it's something that will happen automatically without us actively working on it. So I want to thank you all for giving us a chance to share some of our thinking and some of our research and some of our learning here. And thank you also for contributing and participating and helping us understand the challenges and opportunities that you all say. It's been a real pleasure. Thanks very much. And with that, let me turn the podium over to my real boss, Bob.
I'm not mic'd, so
Oh.
Actually, I really wanted to use
Very
one of these.
creative. I don't know if a machine could have thought of that.
This was actually my choice. Thank you, Eric, and thank you, Andy, and thanks everybody for being here, and particularly thanks all the great speakers. So that was just a terrific flyby on technology, but I think what this was really about was humanism, which is because technology without the human consideration is really just a tree falling in the forest. And I think this IDE, the Initiative for Digital Economy, is it's the only place I know of, or at least the best place I know of, that's really thinking about this. And they didn't just start thinking about it. It's been underway for a while, and I think it's really important. So I can't get up in front of anybody and not talk about MIT a little bit more broadly. It's an irony that as everything is changing so quickly, MIT has been in the front of technology, which has really changed our world, for 150 years. And it's remarkable that MIT's endured so long because when you think about other organizations, like countries or companies, I don't think anyone here can give me more than 5 companies or countries that have existed as long as MIT has. And I say countries, I mean, in the current form of government. Sort of a tremendous irony. So I was thinking about Andy's thing about is it Hippo what was it, highest paid person's opinion. And so when I think about why MIT and other universities like MIT but only a handful, have endured so successfully for so long, I was thinking about that. First of all, it's not based on opinions, so MIT of all places. It doesn't just do it on opinion, it does it on facts and data. And highest pay, nobody's paid anything, by the way. And I guess most importantly, no one's really in charge, which is kind of what this was all about, I think, right? Right, Eric? I mean, that, you know, it's been sort of a collaborative effort, you know, at MIT, but a collaboration among whom? Among yourselves, ourselves, the faculty. I mean, it really has been one of the great collaborative enterprises in the history of the world. You know, the American Research University enterprise, which really MIT helped create, but not alone. So support MIT, get involved. It's all about engagement. You know, who owns MIT? We do. I mean, some of us went to MIT, some of us didn't, but MIT belongs to the world. That's, we have a campaign going. Support the campaign, support this initiative in particular, because that's why we're here, with your thoughts, with your ideas, with your leadership, and, you know, with your money. I'm sorry, I'm chairman of MIT. That's my job. I get paid. Well, sort of, that's my job. Paid is another subjective term. You know, I'll just say this, that you know, some people think we lose money on everything we do. About half of the operating budget of MIT and other universities that are like us come from eleemosynary sources, meaning from us. So it's not that we lose money on everything we do. We just are able to do twice as much with the money that we get. And that's been, that has been, to my way of thinking, the most enduring, successful business model ever invented. That we just do it on our own. Like a lot of the people who contribute to this digital economy are not doing it for profit. So anyway, I'm the only thing standing between you and a drink, which is being served downstairs. Please join us for drinks and support MIT. Thank you.